I thought I was done on the skulls, but we got one last part. But we're sticking with the mouths, but we're really just going inside and talking about really the throat. So this is part 6, part 2. The general structure of a ape throat allows them to eat, drink, and breathe at the same time. Yeah. And that reverberation chamber of a throat, just like with us, allows for the typical range of sounds that primates can make: whoops, hollers, and screams, and stuff like that. But what they can't do is break those sounds into little bitty pieces and do what I'm doing right now, which is it's called modulation. They can't speak. They just don't pack the gear, so to speak. So over the past decade or so, there's been a debate about whether or not Neanderthals could speak as we know it. That was due to the discovery of a Neanderthal fossil with this bone right here. It's called the hyoid. It's a U-shaped bone that sits right under your jaw, and it anchors tongue muscles as well as help you swallow. Maybe you can feel it for yourself, as you can see at the top, but this is an important term: anterior, which means from the front. Okay, so then as opposed to posterior, which means from the back, so post. And then right lateral, so lateral's to the side. If you know football, then there you go. So this bone actually isn't connected to any other bone in the body. So the Neanderthal that we found in a burial, it basically just had it laying next to it, because once the things that it was connected to had decayed away, it was basically left on its own. So could Neanderthals speak? The answer is we don't know. We know that they had the FOXP2 gene that's linked to speech, but the FOXP2 gene isn't just for regulating complex vocal communication. It affects motor skill, brain development, and even bone formation. And that's pretty cool because it actually shapes the body to make it more able to communicate vocally. The variant of the FOXP2 gene that humans have actually has a small tweak. There's 2 amino acids that are flipped around or tweaked in some way. Based on available research, Neanderthals and Denisovans both had the variant of the FOXP2 gene that humans have. But the bones that we were able to extract DNA from to get that evidence come from a time and place where human contact was known to have already happened, or at least the possibility was very high. So you know my rule: if it's post-human contact, we really can't use it in order to definitively answer the question, could Neanderthals or any hominin speak? Who knows? Our variant of the FOXP2 gene may be a dominant gene. I personally would feel like I'm being a little bit dishonest if I considered that to be proof that they could speak. We know Neanderthals had a larger larynx or voice box than us, but that actually shifted the range of sounds that they could make. It was more of like a nasally sound based on computer models. But we don't really know like the full range of motion that the muscles connected to their hyoid bone was. There's a lot we don't know. Like they could make ooh and e sounds, but not ah, because it sounded more like a But could they modulate? The truth is, the reality is probably going to be somewhere in between these two. But based on their abundance of ape-like facial features, it'll probably be closer to this side of that spectrum. Personally, I don't think that before hybridization they could speak. But who knows? I could be wrong. It's not about being right, it's about getting it right. I'm Java, this is Gabademics, and here's some howler monkeys.